This is Unit 11, Section 6 Notes, Fundamental Trig Identities, Part 1, which should tell you there's a Part 2. Okay, before we do any of these, this first section is Quotient and Reciprocal Identities. Well, we got to know what those are first. Okay, so we have, I'll just go through all these. Some of these we know. Actually, I think most of these we've already gone through. Alright, so a quotient identity would be tangent theta equals sine theta divided by cosine theta. So that is a quotient. That's why it's a quotient identity. Then the other one, opposite of tangent, is cotangent theta. And we just flip the one above, so cosine theta over sine theta. Okay, those are the only two quotient identities because they're the only two that are dividing as far as what we need here. Okay, so there's two quotient identities. There are 6 reciprocal identities. But again, we've done these, so they hopefully will look familiar and be very easy. Okay, so the first one is sine theta equals 1 over cosecant theta. And then we flip it, cosecant theta equals 1 over sine theta. Which really all that means is if I have sine, I can flip the number or the fraction to get cosecant, and if I have cosecant, I flip it to get sine. That's all that is. Okay, the next one would be cosine theta is 1 over secant theta. And then again, flip it. Got secant theta equals 1 over cosine theta. And the last two, tangent theta is 1 over cotangent theta, and cotangent theta is 1 over tangent theta. Okay, so those are the two. Okay, so these two right here are quotient identities. The other 6 are reciprocal, because remember, reciprocal just means inverse, right, or 1 over whatever you have. So again, we've gone over these before. Now we're just going to use them for these problems. Okay. Number 1, if secant theta equals square root of 2 over 7, find cosine. Well, we just wrote down here that secant theta is 1 over cosine. Okay, so it's the opposite, the inverse, the flipped version, whatever you want to call it. So to get cosine, I just flip secant and I'm good to go. Okay, so I'm going to show my work just so you know what I'm doing. So we have cosine theta, that's what I want, is 1 over secant theta. Okay, so I take my secant theta right here, square root of 2 over 7, I flip it. 7 divided by square root of 2. Now, I cannot have a square root in my denominator in the bottom, so I'm going to rationalize it by multiplying the top and bottom by the square root. Alright, so now I have cosine theta, and the s disappeared, there it is, equals, so if I multiply these, I multiply the top 2 right here, so I get 7 square root of 2. Multiply the bottom 2. Because they're both square roots, I can do 2 times 2 and get square root of 4. And then I can simplify because I know square root of 4 is 2, so I would just have 7 square root of 2 divided by 2. And that's it. So I took secant, flipped it, rationalized the denominator, and I'm done. Number 2. Okay, this one, notice I gave you 2 things because you will need them. If cosine theta equals negative 1/2, tangent theta equals square root of 3, find cosecant. Okay, well, if I want cosecant, if we go down here, cosecant is 1 over sine. or sine is 1 over cosecant. So if I can find sine, I can flip it and get cosecant. That's what I want. Okay, but if I look at what I have cosine and tangent. I don't have sine. Okay, and this is where the quotient identities come in, the first two we did. Notice on here, I have tangent, I have cosine. If I have 2 of 3 things, I can find the missing thing, the sine theta, flip it and get cosecant. That's what I'm going to do. So I'm going to use this identity, plug in what I have, solve for sine, flip it, and go from there. So let's do that. Okay, again, I'm going to go ahead and show my steps so you can see what I'm doing. So I have tangent theta equals sine theta over cosine theta. Okay, tangent, I have tangent right here. So that is square root of 3 equals sine, I do not have yet, divided by cosine is right here, negative 1/2. Okay, if I want sine, since sine is on the top of my fraction, all I simply have to do to get rid of negative 1/2 or to move it is multiply by negative 1/2. Because I'm dividing by negative 1/2, the opposite operation to move it to the other side of the equal sign is multiply. Okay, so that gives me, I'm going to go ahead and just write sine theta first, because it's the same thing as writing x equals, you're solving for x. So sine theta equals, if I multiply, this square root of 3 is the same thing as over 1, right? So I multiply the top two numbers. Well, first off, it's negative. Let's do that. Okay, top two numbers. 1 times square root of 3. Square root of 3. Okay, bottom two numbers. 2 times 1. 2. That's it. Now, that's not my answer, because again, I am actually looking, wow, go away. I'm looking for cosecant. So I have sine, now I can use that and find cosecant. So I have cosecant theta equals 1 divided by, or 1 over sine, sorry. I mean, it's divided by, but 1 over sine. So I'm going to take sine and flip it. Okay, so here's sine. Now I have cosecant theta equals negative. If I flip that, you would have 2 over square root of 3. Okay, now look, we got to rationalize the denominator again. No biggie. Remember, you multiply the top and the bottom by the square root. Okay, that gives me cosecant theta equals negative. I do 2 times square root of 3 is just 2 square root of 3 divided by square root of 3 times square root of 3. Because they're both square roots, I do square root of 3 times 3 is 9. And I can reduce the square root of 9. So my final answer is negative 2 square root of 3 divided by 3. Now, if that fraction is able to be reduced, then I could, the two outside numbers, if they can be reduced, I would do that. In this case, I can't. So that's the first part, A. Okay, so again, these are identities we've already gone over. I'm just using them now to solve for specific answers without having a graph or a triangle or anything like that, because at this point I don't need it. We aren't using the unit circle right now. Okay, B, Pythagorean identities. Okay, I need to know what those are. So there are only 3. However, there are different ways you can write those 3, and by writing them all the ways you can, you would end up with 9, but it's really just 3. So I will go ahead and give you each one and show you how you can rewrite it. I think that'll help, because then you already have it set up for whatever you need. The first one, the most basic one, is sine squared theta plus cosine squared theta equals 1. That is actually Pythagorean Theorem. That's like a squared plus b squared equals c squared. And if you'd like to know where that came from, I can just, we have our unit circle right here, right? Remember, a unit circle, the radius is 1. That's our hypotenuse. And if we draw a triangle in there, Remember, x-axis is cosine, y-axis is sine, and then our hypotenuse is 1. So Pythagorean theorem would be cosine squared sine squared a squared plus b squared equals c squared. 1 squared is still 1. Maybe that helps to understand where this comes from. If not, you don't really need to know that. Just kind of, cool information of where that came from, why it exists. So that's why it's a Pythagorean identity. So sine squared plus cosine squared equals 1. I can rewrite this in two other ways. Let's say that I want sine squared only. That would be the same thing. So if I move cosine, it'd be 1 minus cosine squared theta. Or let's say I want cosine, right? Cosine squared, I can do 1 minus sine squared theta. So it's just two more ways to write the same one on top. So it's not three different ones, it's the same one. I just rearranged it. Okay, the next one would be, this is the next Pythagorean identity. We have tangent squared theta plus 1 equals secant squared theta. Okay, now I can rewrite this two different ways, or two more ways. That gives me secant if I want it. But let's say I don't want secant, I can do secant squared theta minus 1. That would give me tangent squared theta. Or if I had both, or whatever, if I wanted to do this, I have secant squared theta minus tangent squared theta, and that would give me just 1. So if you need that to verify something, or however you want to use this, depends on what you have. And the last one we have, I guess I'll do a different color, is cotangent squared theta plus 1 equals cosecant squared theta. Now the way I remember these, just remember where does secant and cosecant go with? Cosecant goes with cotangent. So co goes together. Sine, cosine go together. That one kind of probably sounds more natural, and you've been doing that one a lot more. So sine and cosine go together. Cosecant, cotangent go together, which only leaves tangent and secant, which, whoever's left over, they just got put together, right? Okay, now, two different ways to write this last one. Let's say that gives me cosecant. What if I want cotangent? I can do cosecant squared theta minus 1 equals cotangent squared theta. Or just like the last one, I can just do cosecant squared theta minus cotangent squared theta, and that would give me just 1. Okay, so the actual Pythagorean identities are the ones on top. So those are the actual ones, the official, if you want to call them that. The ones below are just ways to rearrange depending on what you need and what you have. But we're going to use these plus the ones up here that we just did to answer 3 and 4. And trust me, these are not going away because, again, this was part 1. Part 2, we're just going to keep using them. Okay. Number 3, if cotangent theta equals square root of 3, find sine theta if the angle is located in quadrant 1. Okay, I have cotangent. I want sine. Okay, first off, let's go find cotangent. We have cotangent down here. Okay, cotangent goes with cosecant, right? So we have cotangent and cosecant. So if I have cotangent, that would give me cosecant. And I know if I flip cosecant like we did just above, cosecant flipped would give me sine. So I'm going to go ahead and use that identity down there to find cosecant, and then we just flip that answer to find cotangent. Okay, so let's start. I'm just going to start by writing the identity that we have. Okay, I want cosecant, so we want cotangent squared theta plus 1 equals cosecant squared theta. Okay, now I'm going to replace cotangent with square root of 3, right? And it's squared. Notice we have the little square there. That means I am squaring the answer. So I have square root of 3 squared plus 1 equals cosecant squared theta. Alright. Now, square root of 3 squared is square root of 3 times square. You know, if you square a square root, the number just comes out. I'll just say that. We've done this before. It's, a while ago. So you square a square root, you just have the number. So 3 plus 1 equals cosecant squared theta. I can add 3 plus 1, right? You get 4 equals cosecant squared theta. Okay, now, because we have this little square, we have to get rid of it. So we do square root, right? And square root of 4, of course, is 2. And that gives us cosecant theta. Now, we have cosecant. We can flip it to get sine. The other thing, though, is the reason it mentions, okay, maybe you're probably like, why does it mention quadrant 1? Okay, quadrant 1 will tell you, depending on what I'm looking for, if it's positive or negative. So if I have the little chart that we did earlier in section, what was that? 5? I think it was 5. Yeah, section 5, we have the little chart. And if I'm in quadrant 1, that means I have positive cosine and positive sine. Okay? So because I'm looking for sine, this answer will be positive. If it was, depending on where it was, it would make sine negative. Okay? So you got to pay attention to the quadrant. Okay, so it's positive. We don't have to worry about changing the sign. But now, I take, let's see, sine theta equals 1 over cosecant theta. So remember, I'm just taking cosecant and flipping it. So sine theta equals, if I take 2 over 1, right, because this is down here, this is like a whole number is over 1. If I flip it, you get 1 over 2. And that would be our answer for that one. So again, you just got to see what you have, see what you need, and plug it in and solve, right? In this case, we had to plug it in and then flip it. Number 4, last one. If cosine theta equals negative square root of 2 over 2, find sine theta if the angle is located in quadrant 2. Okay. So cosine, so I have cosine, I need sine. Alright, so it's down here. I have cosine, I need sine. So I can use, if I have cosine, right, and I want sine. This one right here, this version, is sine squared theta equals. So I already have it set up to give me what I want. I'm going to plug it into this one. Okay, so let's write that down first, and then plug in what we have. So we have sine squared theta equals 1 minus cosine squared theta. Okay, now sine squared theta equals 1 minus cosine squared. Well, here's cosine because we have it in the question. So I would do negative square root of 2 over 2 squared. Alright, sine squared theta equals 1 minus, so 2 negatives, right, make a positive, so we don't have to worry about that. On the top, since I have a fraction, I'm going to square the top, square the bottom, right? So square a square root. So square root of 2 squared just gives me 2. And then 2 squared gives me 4. Alright, I can reduce that. So I have 1 minus 1/2. Alright. So 1 minus 1/2 is just 1/2. So I'm going to go ahead and go way up here. So I have sine squared theta equals 1/2. Because 1 minus 1/2, that one's pretty easy. Now we want to get rid of the square. Okay, so I do square root, and that gives me Sine theta equals square root of 1 on top is just 1. Square root of 2 on the bottom is just square root of 2. We can't do anything with that one. But now we have to rationalize the denominator. So multiply. So now I have sine theta equals 1 times square root of 2 is square root of 2. Those are both square roots, so we have square root of 4. Right? And last thing we have, I can do square root of 4. Right? That gives me square root of 2 over square root of 4 is 2. And the last thing I have to check is if it's positive or negative. So I know it tells me we're in quadrant 2, and that is negative cosine, positive sine. And since I'm looking for sine, I leave it positive, so that would be my answer right there. So those are Pythagorean theorem, or identities, Pythagorean identities. And we have reciprocal identities and quotient identities. So you'll be using all of these on the homework. Please practice. This is very new. It is challenging. The only way to understand it, though, is to do it.